Hello, welcome, good morning to everyone. Thank you for joining us. You are joining us on a short presentation about additive manufacturing and how that is used within the robotics and automation industry. So first things first, we're actually going to run a live demonstration of 3D printing for you. So reason being, we have the latest in technology here, which is a printer called the NXE 400. From a manufacturer called Nexa 3D. So you should be seeing on your screens the printer itself. What we're actually running live for you here is we're going to run a batch of 8 robotic grippers, so for end of arm, for robotic arm, and we're actually able to print 8 of these in 30 minutes. So because this is a 30-minute presentation, we thought if we've got the ability to give you a live demonstration, then we should, basically. So we'll leave that up on your screens throughout the presentation, so you can keep an eye on it. First few layers are the slowest, but after that you should see it going up and down, and then towards the end of the presentation you should see the final print. The print itself is done in a material called XCE Black, which is a cyanide ester material. The printer can do a range of different materials, everything from prototyping materials all the way through to functional end-use materials as well. And this particular one is a functional material, so these can actually come off the printer and can actually then be used in anger, as it were. So, as I said, my name is Simon Chandler. I'm Managing Director and Founder of CREAT3D, and I'm also joined today by my colleague.
Hi, I'm Sachin Patel. I'm Major Accounts Manager and Application Specialist here at CREAT3D.
So, quick overview of what we're going to talk about today. We'll give you a little insight as to who CREAT3D are. We'll also then talk to you about the different AM technologies that we have for robotics and automation, and a quick overview of the AI system that we use as well. Sachin's going to take you through some of the customers that we work with who are in robotics and automation and how they use AM. And obviously, as you can see, we're doing a demonstration, and then we'll finish with a live Q&A as well. So the reason why CREAT3D exists, basically we work with customers to understand how AM can be integrated into their business to give them cost savings and efficiency gains. That's the crux of what we do. How we do that is we work with them to really understand their businesses, and we understand the challenges that they're facing, the problems that they have. And then we help them to understand how AM can solve those challenges. We also then provide all of the actual 3D printer hardware, and we provide ongoing services. So things like installation, training, like technical support services. We also provide all the consumables, spare parts, and everything that wraps around the whole life cycle of owning and running a 3D printer. Also, if you work with CREAT3D, you benefit from getting access to people like Sachin, who's one of our applications engineers, and they work with our customers to really make sure they're getting the full benefit from the printers themselves and really using them to their maximum with the capabilities that are available now. We offer a range of different technologies within additive manufacturing, so everything from desktop prototyping devices, whether that be FDM or resin-based, all the way through to things like large format FDM, also carbon fiber composites, metal 3D printers, and what we're seeing today, which is the high-speed resin-based as well. And we offer generative design software as well. In terms of who we work with, it's really any business involved in design or manufacturing. So it is mainly engineering and manufacturing companies. As you can see there, we obviously work with multinationals, but we also work with owner-managed businesses, SMEs, medium-sized enterprises, all the way up. The thing that combines all of these different customers is that they want to make their business better. And we can provide additive manufacturing technologies that enable them to do that. So the reason that we're talking to you today is because we have a number of customers which work within robotics and automation. To give you some background, the journey that most of these customers have been on is that they wanted to bring on 3D printing into their business to help with prototyping in the first instance. That was the main driver. Within prototyping, really, there were two areas that they were looking at. So the first one was prototyping of components that would actually go on the robot arm or onto the equipment that they manufacture, but also prototyping of things like jigs and fixtures, which they then use within their traditional manufacturing processes. The interesting thing is that as they integrated this technology and as the technology improved, what they found was that it wasn't just a tool for prototyping. They were actually able to produce prints which were then functional enough to go onto their equipment and actually be used in a live environment. The reason that they would do that is really they found that the prints were not only faster and cheaper to produce in a number of cases, but that actually the prints themselves then meant that the equipment that they were producing became better, it became more functional. They were able to run it faster, for example. It had greater longevity to it. So they found that they were actually able to use AM to build better machines, which obviously then benefits their customers because they're getting a better product. The other benefit that they found was actually a business benefit. So they were actually able to lower their cost of production. They were actually able to make their current production more efficient, and they were able to produce components through 3D printing, which again lowered their costs, reduced their lead times, and of course therefore made their own business more efficient. So there's a number of areas which AM is now being used within. So a quick overview of the main technologies which our customers are using. So the first one is the technology we're demonstrating today, which is a high-speed resin process. This is being used obviously for high-speed prototyping. So as we're showing you today, we're able to produce 8 different grippers in half an hour. So in terms of being able to iterate a high number of versions in a very short space of time, but because of the speed, that also crosses over into being able to produce batches. So whether that's small batch productions of ones, tens, or even into the hundreds or thousands in some cases, you're actually able to produce components on a batch size large enough for the kind of quantities that most of our customers are operating with. So a little example of the print times. So you see at the bottom there, we were able to produce 6 of these joysticks in 45 minutes. Also at the top there, you can see swabs. So we don't want to mention COVID if we can avoid it, but 800 COVID swabs in a medical grade material, 3.5 hours, so 16 seconds per swab. Another technology that's being used increasingly is metal. So this is a relatively low-cost process. There's 3 stages to the process. The first one is the printing, which is an FDM style process. So the feedstock for this is a filament, which has 3 elements to it. The first one is the metallic powder, which is bound within a polymer and also a wax. After the print's completed, it then goes into a wash, where the wax is washed out. And after that, it then goes in a sintering oven. And that sintering oven takes out the polymer and also then sinters the powder together to create the final metal print. There's a range of different metals that we can print in. So 17-4 stainless steel, 3 different versions of tool steel. So this is used in basically making current production methods more efficient. So that's A2, D2, and H13. There's also then Inconel, which is high temperature metal used in things like rocket engines. And then the final one is copper, which is used for things like heat sinks or welding shanks, which is quite an interesting one as well. The key thing with these metal parts is that you can actually create much lighter parts than you can through things like CNC machining. And the final one, which is probably the most widely used at the moment, is composite 3D printing. So this is a kind of hybrid FDM approach where we are extruding plastic out of a nozzle, but we're also inlaying a continuous strand of fibre, whether that be carbon fibre, fiberglass or KEVLAR. And the reason that we're using this process is because you're able to produce prints that are lower cost, but higher strength, higher stiffness, higher wear resistance, and good temperature resistance as well. And obviously you're able to produce these on demand, and you're able to produce more complex designs than you would through traditional methods. So I'll pass you over now to Sachin, who's going to take you through some real life applications of where this technology is being used.
Oh, thanks, Simon. Right. So just before I actually get into some specific applications, I wanted to cover how additive manufacturing is being applied in industry today, and really the journey that we've seen. So 3D printing has been around for 30, 40 years, and certainly since I started 7 or 8 years ago, additive manufacturing has only ever really been suited for prototyping, R&D, and generally supporting the design cycle. What we've seen more recently is this sort of slow development over time, from the early days of using additive manufacturing for the design cycle and prototyping, through to where we are now, where there's been a development of materials and technologies, speed, like we're showing you today, and reliability as well. So this will see more of a movement into things like production aids, functional parts like jigs and fixtures, and end-use components as well, which we'll be talking about a bit later. What I wanted to talk about on this slide basically covers sort of 3 key areas that we're seeing additive manufacturing being used, and specifically in the robotics industry. And some of the applications I'm going to mention later cover off these key areas. And that's rapid prototyping, bespoke production components, and manufacturing aids. So just to step through those, rapid prototyping, something that 3D printing has been used for a very long time. And a lot of our customers within the robotics industry have used 3D printing for rapid prototyping for many years. You know, the ability to have a fast iteration of design ideas, meeting customer demand, and actually offering clients same day and immediate feedback on designs and engineering solutions has been valuable for a lot of our customers sort of since the early adoption of 3D printing. What we're seeing now is things like bespoke production components. So the ability now to print end-use components without the limitations and costs of mold tooling or lengthy machining setup, and bespoke one-off components all the way through to mass customization of larger batch components like Simon mentioned earlier. The other real benefit is the ability of using additive manufacturing now actually enables parts to be optimized for the additive manufacturing process. The long-term benefits for that include things like ease of replacement for high wear components, and fast turnaround for spares. So when things are things fail, or they fail due to high wear and tear, everything's actually stored in a digital inventory. The parts are there, they're designed for additive manufacturing, and they can be printed on demand. So you're able to get a client who has your equipment on site, you can print them a part, and the next day they can have that part ready to be installed. Right, so just diving into a couple of examples here of real life examples of our customers who are using 3D printing today for a range of different applications. The first one here is a company called Technolog. We've worked with them for a few years now, and they've got a few Mark IV 3D printers. The company basically developed highly customized special purpose machinery and automation solutions for a range of clients, from aerospace to automotive. They sort of started similarly to what we see a lot with a lot of our customers. They started bringing this technology in for rapid prototyping and form and fit, and now they've really truly fully integrated additive manufacturing into their entire design and manufacturing workflow, right from the early stage prototyping and functional tooling, all the way through now to end-use components. And this is a really great example of that. This cobot here is a specialist machine they've designed and manufactured for a client. The end cobot actually has about 20% of the components on it are 3D printed using their Mark IV printer. The great thing with this is, you know, not only are the parts cheaper and a lot quicker to produce, they're actually better performing for the application. So they prove better than the parts if they were traditionally manufactured. Moving on to another customer in a similar sort of industry, Expert are a solution provider for bespoke tooling and automation. They supply a whole range of industries as well, from aerospace, medical, and automotive is a key industry they supply. The guys there bought their first 3D printer in their R&D team, and it was specifically for prototyping and proving proof of concept stuff. What they quickly realized is that 3D printing had developed quite a bit since they saw sort of plastic things at trade shows and things like that. So the Mark IV technology they had actually gave them the ability to move into what the real true value of having this kind of technology is, which is end-use components, jigs, fixtures, and those sorts of things. And again, they fully integrated additive manufacturing into their manufacturing process. They have around 5 or 6 3D printers now that sit amongst their CNC machines and other machining capabilities. This part here is just a simple jig. By printing this, they saved, I think that's around 96%. So it was around £300 to machine the part. It costs about £10 to print it. But the real benefit for their engineers was the lead time. You know, they didn't have to get purchase orders raised and all that sort of stuff to have an outsourced machine component arrive 3 weeks later. They were able to set this off in an afternoon, and the next morning they had the part in their hands, which is really valuable. And then just one final example here. This is another customer of ours who we worked with for quite a few years, have a whole range of different 3D printing capabilities. Activate Robots design and build high-performance end effectors and gripper systems for industrial robots. You know, with bespoke solutions being a core part of their business, being core to their business, additive manufacturing was always a clear choice for their design and development workflow. From those early stages, it not only reduces the iteration time in terms of finding the right form and fit for their end effectors and components, but it also significantly reduces the cost and overall lead time of actually getting the part developed and designed for their client. Real benefits for them come from producing lighter components. So as Simon sort of touched on earlier, components are lightweighted, which allows them to create, basically maximize a robot's available payload. So you imagine light components, faster moving robots, much more efficient for their clients. The great thing and the great example with these guys is the printed end effectors and the printed grippers they were producing were actually proving more efficient for the job than traditionally manufactured parts. And in most cases, the printed parts would actually outperform the robot itself. So they were more than capable for the job at hand. The light weighting of the entire robot arm actually leads to less wear and tear as well. So from a client's perspective, that's brilliant. There's less chance of things going wrong. So just talking about lightweighting for a moment. Really great example I wanted to mention here was a global automotive manufacturer. We're not allowed to say who they are, but they have a bunch of Markforged machines and Markforged Metal X printers that they're currently using to print a welding shank, so copper. They're using the copper and the Metal X to print welding shanks for essentially end effectors on their robot arms on their production line. they're cheaper, they're quicker to produce than traditionally machining them. But the real benefit for them is the lightweight. So the Metal X actually allows you to print with a honeycomb structure, so immediately you're lightweighting the components. Similar to what Activate do, the lighter end effectors, the lighter grippers, and in this case, the lighter welding shank allows the robot arm to move quicker, speeds up production line. I think it's about 4 seconds per car, which doesn't sound like a lot, but you imagine how many cars are flying through this automotive manufacturer. You know, the savings in time increase per car, and the cost hundreds of thousands, if not millions of pounds saved. And lastly, I just wanted to talk a bit about design. So recently we've been working a lot with our customers. A lot of what I do is supporting with the idea of moving from design for traditional manufacturing, design for injection molding, design for machining, and thinking about design for additive manufacturing. And the real value, where you get the real value from using 3D printing, is by trying to adjust your designs to better suit the technology, as you would do with designing for machining or designing for injection molding. So we've sort of seen that step into understanding additive manufacturing more in designing for the technology. Now this is sort of the next step up into that sort of space, which is generative design. It's been used for a while in industry, but now we're getting to the point where it's much simpler, much cleaner to use. Essentially, what generative design does is it essentially lightweights a component that would have been manufactured or designed to be traditionally manufactured. What it does is it strips back all of the unnecessary weight and mass of the component to the bare essentials, to what's actually needed and required for the part to function as intended for the application. And the key thing is, without the bulkiness and without the weight of the part, if it was designed for machining and molding. This specific part here was, I believe it was done in a software called Parameters, which is software that we work with. It essentially makes the whole generative design process a lot easier, much more efficient, truly optimizing parts for additive manufacturing. Right, and I think we will be heading back to the printer now to see how we're getting on with those grippers. Right, so it looks like we've probably got about a minute or so left on the printer, but as you can see, it's working its way through. It's just at the final stages. You can actually just see it lifting through the last couple of layers, and that movement is layer by layer printing and curing. So see how fast it is. And yeah, it should be about a minute, so we should see that finishing. Cool.
So just to summarise, hopefully we've kind of got across how AM is being used. When we first started working with a lot of companies in this sector, AM was seen as a complementary technology. And I think the really great thing now is that it's not just seen as a complementary technology, it's seen as being completely integrated into what they do as a business. It is entirely integrated from the initial design phase of a component all the way through then into the production of that component, and then also further into the full life cycle of the machine. So stock parts, wear parts, as Sachin said, the ability to have a digital warehouse of components, so that you're not only making the machine that you're creating as functional and the best product possible, but also from the business side of things, you're creating something that is efficient and for the full life cycle of product has the lowest possible costs of maintaining that product as well. So yeah, AM is fully integrated now into robotics and automation. So the printer should be finishing shortly, and then once you've seen those parts, then we'll move into the Q&A. So there you go, good timing. So as we said, that's about half an hour, and we've produced 8 robotic grippers. So that is that. So thanks for your attendance. And again, feel free to now submit questions and we'll do our best to answer them for you. Thank you.
Thank you.
Thank you very much for that presentation. I am now here with Simon and Satchan, and we will be answering some of the questions that we've come up with and that we've seen in the chat. So the first question I have for the both of you is from the chat, and they ask, how do you manage QA, so quality assurance, on such a range of items, many of which may be bespoke?
Cool, good question. Short answer is we don't. So as a business, really, the bulk of what we do is we supply the printers to customers, to engineering and manufacturing companies. So really, it's a case of them producing these items and then going through their own testing and verification processes.
Yeah, and just to add to that, yeah, Simon's obviously correct with that. What we're seeing a lot, obviously, is there is a clear importance in things like quality assurance and checking dimensional accuracy, and that parts are within tolerance if printed once, twice, 100 times. So a lot of the manufacturers that we work with, a lot of the technology we work with, that are, you know, they understand the importance of it and they're developing ways to support quality assurance. Like the Markforged printers, for example, they're building things in place for in-print scanning and inspection, so that the parts are always within tolerance. So yeah, it's certainly an important thing, and manufacturers are aware of that.
Yeah, I think also for some aspects of the testing, obviously the material properties is important. So there's a lot of work going on with getting materials and the whole production process of creating the raw material that's then used in the printer, getting those certified to certain levels. So for example, that might be medical grade materials, that could be things like aerospace grade as well. So getting the materials certified, and actually the printer itself certified for producing parts that can then go on planes, for example. So yeah, there's a lot of work being done. I think it's one of the biggest areas where 3D printing needs to progress to really come on stream with current manufacturing technologies.
Yeah.
So just speaking to you a bit earlier, we were discussing the fact that you were saying that the biggest hurdle you overcome is educating people on what a 3D printer truly is and what it actually means and what you can actually effectively do with one. Could you just go a bit more in depth on that for the people in the live stream? Yeah, certainly. So what we see really is that a few years ago, kind of 2013, the media really got hold of additive manufacturing, and the term 3D printer became really widely known, but there was a big hype around it. And a lot of our customers investigated 3D printing back then, were expecting something that was, you know, amazing and could do a million things. And what they found was that the technology readiness level was not actually there. Fast forward to today, there's a lot of companies who are a bit jaded by it all and haven't necessarily looked at what the technology can do for them today. So really what our job is to speak to customers and understand what they do, and then help them understand where the technology actually is today and what its capabilities are and where it can be used in their business today to have a big impact. And we're almost blasé now in that when we're talking to customers and we come across an application that saves them 90% costs and 90% lead time, that's pretty bog standard, really. Yeah, don't know if you've got anything else to add.
I think similar to what Simon's saying, it's key things like the terminology and where we are now. You know, even the term 3D printer, you know, I try not to say it at all during my working week, but yeah, I mean, it's a manufacturing tool, and that's one of the key things when we're talking to people who potentially the last few years thought it was a magic box or prints plastic toys. You know, where we are, it's a manufacturing tool, it's a manufacturing aim, and that's quite a clear thing that we try and get across.
Brilliant. So that actually is quite well into my next question, which is what personally in your time working with this company and just with 3D printers, what's your favorite use of a 3D printer to solve a problem that maybe wouldn't have been thought of being solvable with 3D printers?
Oh, there's so many.
Yeah. Yeah, I mean, there are quite a few. So quickly, there's some really cool stuff being done with copper printing. So for things like welding shanks. So it sounds a bit geeky, but basically I think we touched on it in our presentation, but there's a car company who printed welding shanks instead of machined them. So they were lighter. And so their car production line runs like 4 seconds quicker. And for me, yeah, I'm passionate about manufacturing. So to hear about a small thing like that, which when scaled up and the volumes that you're talking about, has a multi-million-pound impact on a business, just from printing a welding shank, that I think is awesome. It's really cool.
And that said, there's loads, but I'm trying to think of some now.
Yeah, some of the high-speed applications. So because of the latest generation of printers, print stuff in minutes. Just a silly thing. We had a customer who they had a meeting. Their customers came in. They were doing design changes on a prototype with the customer sat in the room. Then they went away and had a coffee and took the design changes off, printed it. When they then came back and sat down in the meeting, they then brought a print into that meeting. So within like an hour and a half, they'd iterated a prototype and had it in their hands. And the power of that, it's amazing.
Actually, sorry, I was just going to give one more example of based on the high-speed printing side of things. I was working with a customer who invested in 3D printing a couple of years ago. It's completely revolutionized their business. And they use them as production machines. They had a part that takes about 2 days to print at the moment, which they were more than happy with. It's still a quicker than 3-week lead time to get in from an outsourced supplier. But yeah, with some calculations, we printed the same part. I think it was in 2 hours on the Nexa printer, and we figured out that I think we could cover a month's worth of their backlog, a month's worth of printing in a day's print on the Nexa 3D.
On the high speed one.
On the high speed printer. So yeah, stuff like that really excites me.
Yeah, and so that's basically the stuff that we get excited by is the cutting edge stuff of 3D printing. That seems to be the case. Yeah, the new materials, the high speed stuff. Yeah.
Oh, we love to hear it. It's amazing. And just one other question from the chat quickly, because we've got another last quick minute. Can you discuss more about electronic integrations in printing and designing with wiring in mind?
Yeah, well, there's a few different options. Depending on the technology that you're using. So, for example, if you're using more of an FDM-based technology, there's no reason why you can't design in recesses and channels and actually embed components within the print. That's an option. Yeah.
So that's the key one.
Yeah.
We've come across. Yeah.
I guess also there's the potential for using something like an ESD safe material. Yeah. If you want more specific stuff, we can probably pick that up offline actually. Yeah.
Oh, brilliant. Well, thank you so very much for coming. It's been so fascinating hearing from you guys on all the stuff that you guys are getting up to.